All right, we're going over the OpenOak quiz here. Um, First one we got true. A chemical equation is balanced when it shows an equal number of atoms for each element on both sides of the arrow. So example here, two hydrogens, two hydrogens, two chlorines, two chlorines. You balance by changing the coefficients. You cannot change the coefficients or the numbers in front. You cannot change the formula or subscripts. Insoluble means that it is in a solid state of matter. It is in an aqueous state of matter if it's soluble. That is a solid dissolved in water. So number 4, what could this be best read as? So the most specific is best. That would be letter B. 1 molecule of hydrogen gas reacts with 1 molecule of chlorine gas to produce 2 molecules of liquid hydrochloric acid. Makes note of the state of matter symbols, how many molecules are in it, and so forth. Why are aqueous and liquid not the same thing? Aqueous is a mixture of that solid and water, and liquid is you can think of it as a pure substance of that compound or element. And they're not the same thing because aqueous is a mixture, it's dissolved in water. Liquid is something else. So decide whether or not the reactions will occur. So that the element that's in red here, the thing that's by itself, has to be higher on the solubility curve than what's replacing. So here K has to be above Fe. And then for my next one, it's going to be Na has to be above Al, and here H has to be above Ag. So now I'm going to look at my list. First one is K above Fe, scrolling down. K is above Fe, there's K, there's Fe, so that one will occur. So the reaction will occur, that would be letter A. And Na has to be above Al. Right, that's what I said. Yep, Na has to be above Al, so I'm going down. There's Na, it's above Al, so yes, that will occur. It'd be letter A as well. Next one, H has to be above Ag. I'm just going down until I see H, which is right there, and whereas it's above Ag, so the reaction is, yep, that one will occur too. All three of these will occur. Next one, either my compound is going to be A, this first compound, B, that compound, or C, both are going to be aqueous. So I have to use my, what's it called here? Oh, my solubility rules. Okay, so first rule says that all acids are soluble. Anything that starts with H for us is going to be soluble. So this one is going to be AQ, and that's my only acid here. Next, it says that all alkali metal compounds are soluble or aqueous. That would be Na, AQ, that would be K, AQ, and that would be Li, AQ. All those are alkali metal compounds. Next, all acetate, perchlorate, chlorate, and nitrate compounds are soluble. I'm looking at the ones that are unlabeled. That doesn't help me for Fe or Ag, Br. Next is silver, lead, and mercury compounds are insoluble. Okay, silver, lead, and mercury compounds are insoluble, so this one is solid, insoluble. Doesn't help me here. Now I'm looking for iron or carbonate rule. Okay, chlorides, bromides, iodides, carbonate right here. No exceptions are insoluble, so that one is solid. So my answer would be letter A. Here I have two aqueous, so that's letter C, no reaction. And here's my second solid, that would be letter B. Okay, decide whether or not the reaction will occur. If it will happen, write the products. Now, for my double replacement reaction, I'm going to have to go ahead and write my products first. Okay, so I kind of have to do it for this one. Okay, so I don't know if that's going to be aqueous or not here. So Na and Ba are switching spots. So Na is going to go right here, and Ba is going to go right here. Now Na and NO3 are both 1s, so it cancels out to just look like this, NaNO3, +1, -1. And here Ba is a +2, phosphate's a -3, so I actually need to crisscross here to put the 2 from Ba onto the PO4. Oh, this is weird looking. Okay. Now I can go ahead and identify them as aqueous or solid. Okay. So, just going through my rules. Acids. I don't have any acids here, so that's fine. Okay. Second rule says alkali metal compounds are soluble. That's this one. That is aqueous. Now I'm looking for something about barium or phosphate. Nothing about barium or phosphate here, or there, or there. Here I got phosphates are insoluble, so this would be solid right here. Okay. Now I'd have to balance that one really quick. So here I got 3 NAs. So I could start, I'm going to start with 1 Ba, 3 Bas. So I need to put a 3 here. Okay, that gives me 6 NO3s. So since I only have 1 there, I need a 6 here. That gives me 6 NAs. So I need a 2 there, and then that will be a 1. So there's my final answer. Yeah, the other 3 are, I have a double replacement down here. Oh, we're just assuming that this one is aqueous down here. Okay. So is iron above aluminum? That's what I'm looking for here, is iron above aluminum. There's aluminum and there's iron, so this one would be no reaction. Fe is below Al. Here, strontium has to be above calcium. Is strontium above calcium? There's strontium right above calcium, so yes, it will occur, meaning I have to switch these. So strontium is going with iodine and calcium's by itself. Strontium, now I have to look at my charges. Strontium's a +2, iodine's a -1. So when I crisscross, I actually get SrI2. Then to balance, it's actually all good, okay, the way it is. Here I got to predict my products again. Again, we're assuming our reactants are aqueous. It might actually not be the case, but we're just assuming that. So here, barium's going with iodine. Ba is a 2, I is a 1, so I get BaI2. That's great. And copper from over here is also a 2, so I'm getting copper nitrate. So let's see if either of these is a solid. For this one I forgot to mention, this is a reaction. Will occur. Okay, first, all acids don't have one of those. Alkali metals don't have one of those. Acetate, perchlorate, chlorate, and nitrate. I got a nitrate. Compounds are soluble, so this one's AQ. I'm looking for something about barium or iodine. Next one, iodide is soluble, so that means that this one is AQ. So this would be no reaction, because both are AQ. Okay, and my last question here, law of conservation of mass states that mass is constant over time. So if I had 15 grams of nitrogen, we don't even need this, stoichiometrically this might not work, but that's okay, are reacting with hydrogen, some amount of hydrogen, goes to make 42.5 grams of ammonia. And you don't even need to know what the products are here. It says how many grams of nitrogen were reacted. Well, based on law of conservation of mass, the total on this side has to be 42.5, meaning the total on that side has to be 42.5. So that means the amount of H2 is equal to 42.5 grams minus 15 grams to give me Mental math is hard. 27.5 grams of hydrogen in order to do that reaction. Again, stoichiometrically, that might not be accurate, but the idea or the principle of it is accurate. All right, let me know if you have any questions. Otherwise, if you felt good about this, you can go right into that quiz, and I'll talk to you guys later. Okay, love you, miss you, bye.